In the next few modules, we will look at different techniques that are used for the digitization of information. We may recall that information can be represented in different forms. One was data, and the other one was image. Then we had audio and video. Now, it is important to digitize them in binary form so that computers can be used for processing the information and digital communication lines can be used effectively to transmit information. In this particular module, we will look at the digitization of data. The way data is digitized is based on a coding system. There are three major coding systems that we can use for digitizing data. The first one is known as ASCII, that is used very widely in the microcomputer area. Then we have ASCII, that is used extensively in the IBM mainframe world. The third coding system is known as Unicode, which is now becoming very popular. The ASCII system and the ASCII system will eventually give way to the Unicode system. In the past, when we connected microcomputers over communication lines to gain access to a mainframe, for example, terminal emulation purpose and so on, it was important that in addition to making protocol conversions, it was important to convert the coding system from ASCII to ASCII as well. Here is an example of the code that used for representing the letter A in the ASCII system. It is 1 0 0 0 0 0 1. So in order to transmit the letter A, if it is based on the ASCII coding system, we would transmit the signal 1 0 0 0 and 1. This has 1 and 5 zeros and 1. This would carry the information or the letter A. This is the basis on which the digitization of data is based. In actual fact, we don't send information on a single character in this way. Generally, we will frame it as a character frame and send the information, or we will assemble a group of characters into something called a data packet and send the information. But here again, the conversion or the digitization of data is based on a coding system. The coding system that was used, that is still being used in a number of microcomputers, is the ASCII. IBM mainframe is ASCII. The new coding system that is much more advanced, that can be used for representing many more characters, is the Unicode coding system that is replacing the ASCII and the ASCII coding systems. The question one may ask is, why do we need a new coding system? If we look at the ASCII systems of the past, what we have is a set of characters that are much limited. In the early days, the ASCII representation was limited to 128 characters, and now it is expanded further. The extended ASCII can represent more than 128, 256, and so on. There is, however, a limitation on the number of different representations that one could have with the ASCII coding system. Now, the Unicode has many more variations that is able to represent in native form the alphabets and the numerical numbers and other characters of the English language. Any European language, it could be represented here. It has the features, or it contains enough variations to represent Chinese and Japanese characters. It also can be used, or it already incorporates representations for 18 of the major languages of the world. For example, one of the languages that's incorporated in Unicode is called Tamil. This is one of the languages spoken in South India by approximately 70 million people. The possibility of representing this many characters and languages is made possible by the fact that Unicode is a 16-bit code as opposed to the ASCII that is fundamentally an 8-bit code. With 16 bits available for Unicode, we can represent nearly 65,536 different variations. Compare that with, of course, the 8-bit ASCII code. So the first one is Unicode and the second one is ASCII code. Now let us look at one of the advantages of using Unicode. For this example, we will look at the setup of a web server to carry information in a foreign language. What are the options available to us? The computer code obviously is based on the Roman alphabet, so anything represented in English is transmitted in binary form, in the form of 1001. So if you want to create a web to transmit information in a foreign language, let's call this language Tamil, T-A-M-I-L, we have a few options available. The first thing is to take each page and scan the page and put it as a web page. This one requires a lot of storage because scanned pages are images. Images require a lot of storage space. That's the first option, that is scan and store. What is the second option available to us? We can use something called a font. We could download a Tamil font and store it in the computer and develop the web pages using this font. In other words, the web page is developed using a particular font. In this case, the storage space and the transmission requirements are considerably reduced because of the fact the fonts enable each of the characters in the different languages to be transmitted in binary form as opposed to the scanned images. So there is much less storage requirement and much less bandwidth requirement when we download the font. In the first case we had scan, the second case we had font. Right now with Unicode, we don't even have to download a font. What do? Because Unicode has Tamil characters built in, we use Unicode. It is possible to simply select the Tamil fonts without having to download or install any fonts and develop the web page in Tamil using the Unicode fonts. Once we have the web pages developed in this way, they can be transmitted using binary signals again that are much more efficient than scanning the page to the client. In order for the client to view this page, he or she need to have Unicode, which is a standard feature in the new computers and the operating system, and by activating that Unicode, he or she will be able to view the pages. So in other words, the Unicode system can be used to significantly reduce the bandwidth requirements and the storage space of web pages that have been designed, that have been created to convey information in a foreign language.